This is gonna either hit or miss. You're either gonna know, or you're not gonna know. Uh, let's see. What do you call it when Batman skips out on church? Christian Bale. All right, here we go. Let's talk about. I'll be back. Here we go. All right, we're talking about concavity and points of inflection. Okay, this is where I think you'll spend majority, like it's a big part of what we're doing. Okay, we've been leading up to this. Okay, now your second derivative. So we learned how to do multiple derivatives. Your second derivative tells us about how to find the concavity of a curve at a point. So remember, first derivative just tells you if your regular function tells you positive, zero, or negative. Okay, above the x-axis, on the x-axis, below the x-axis. First derivative talks about increasing or positive tangent, decreasing negative tangent, or stationary horizontal tangent. Your second derivative now tells us about concavity. You're either concave up, okay, or you're concave down, okay? So see, concavity. I think it was good. Okay, so very similar. We've seen this before, but I'm just going to put it here because it's just specifically talking about concavity. If your double dash is less than zero, that means we're concave down. So I think of it this way. If it's negative, you're sad. Okay, so that means you're concave down at x equals a. If your double dash a, your second derivative equals zero, that means you have a point of inflection. And if your f double dash a is greater than zero, I think your number is positive. So you're smiley, you're going to be concave up. Okay, smiley face. Okay, so concave down is this one, concave up, that. Okay, hopefully that makes sense. So now, instead of using that crazy, like using a table to find your, what do you call it? To find your nature, using the slope of table of slopes to find your nature. Now we can just use your second derivative, which I find personally a lot easier. Okay. And so I've just got one question here. We want to find the stationary points of this guy. We want to determine their nature and we want to hence sketch. Okay, so let's break it down. We're going to do the whole thing. This is a typical stock standard HSC question, and I believe this actually came from a past paper. So let's say first things first, I want to find a stationary point. That means f dash x equals to 0. Okay, so let's go stationary points. First things first, derive it. That becomes 12x minus 3x squared. And I'm going to let that equal to 0. Okay, so 0 equals to 12x minus 3x squared. Now this is a quadratic. I'm going to take out 3x as a common factor. That leaves me with 4 minus x equals to 0. Hopefully that is a correct. Yep, that's a correct thing. So here I can see the values for where I get a stationary point. So either this equals to 0 or that equals to 0. So I can see here that x either equals to 0 or 4. Now remember, I need to find a stationary point. So x is a good half coordinate. I also need the y. So let me do that now. So I'll say when x equals 0, y is also going to equal, substituting into the original. That one there, that's nice and easy. Okay, but when x equals to 4, y is going to equal to, I don't know, let's go 6 times 4 squared, take away 4 to the power of 3. Okay, so I'm just going to do that 6 times. All right, so that becomes 32. Okay, so right now I know that I have a stationary point. 0, 0 is one of my stationary points. 432 is my other one. Now I've done that. Next step here is for me to determine their nature. Okay, so in other words, is it a max? Is it a min? Is it a point of inflection? Okay, the way we're going to use that is we're going to actually use our, instead of using the table of slopes, now we're going to use our second derivative. So let's do that. I've got my f dash x continuing on from that, I can see now my f double dash x becomes 12 minus 6x. Okay, now at this point, all I need to do is I need to test at my first stationary point at 0, 0. Or in other words, I can just text at x equals 0. What happens to my f double dash? It becomes 12, take away 6 times 0. It just becomes 12. Now, the way I like to go from here is if my double dash is greater than 0, that means we're positive. That actually means we're going to have a minimum stationary point. It's kind of like at that point. Okay. Take a little bit of time to make sure that makes sense to you. Let's do the other point. So at 4, 32. All right, we're going to see what happens here. In this case, we only really care about the x coordinate. That's x equals to 4. So that means f double dash 4 becomes 12 minus 6 times 4. That was horrible. But that gives you minus 12. Okay, so what that gives you is that's less than 0. So that's negative. So we're sad face. But that means we're actually going to have a max stationary point. Okay, now if you look at the numbers, it kind of makes sense. And so here's what we've got now. Now we can sketch, because I'm pretty sure the question asked us to sketch. And because I don't need things to be perfect, I'm just going to quickly draw this out. The 2 points that I've got, I know the 2 stationary points are 0, 0. So there's one thing going on at 0, 0. And there's another thing that happens at 432. So I'm just going to say 432 can be somewhere here. Note, for a sketch, I don't need a perfect scale. Now, I do need to understand that at 0, 0. I figured that out from before. That was a min stationary point. Whereas 432 was a max. Okay, so I know 432 is going to be a max. So I kind of draw that in. I know that 0, 0 is going to be a min. Now at this point, I know that it's going to look somewhat like this, and boom, there's your sketch. Okay. And of course, if you wanted to find the other x-intercepts, you could, but it didn't ask for it in this question, so we're done. All right, hope that helps. All the best, and I'll catch you guys in the next one. See you later. Bye.